So yeah, hello everyone. My name is Anton. I'm Microsoft Regional Director and also Microsoft Azure MVP. I'm based in Kyiv, Ukraine, and here you can see my email. If you will have any questions about this session, even after my presentation, feel free to drop me an email. I usually answer them on a regular basis. So today I would like to basically tell you a story about how we built an geo-distributed API based on the Azure Functions for one of the projects. Unfortunately, that project is under NDA, but I will make all of my examples about pretty much a very similar company, pretty much a very similar concept that I was able to found over the internet. So the first question is, why do we actually need the geo-distributed API in the first place? So usually when I'm asked that kind of question, I go for recovery, availability, and performance. So first of all, recovery, in case you have an issue with the data center, with some of your underlying hardware or even like virtual resources, if you have some other copies of your app deployed into the other data centers, you can actually switch the traffic there, and in that way you actually achieve the high availability as well, because now you don't have a single point of failure. And of course, performance. Why performance? Because if you deploy your app globally, if you will have the global presence, in that way you will eliminate the effect of the network latency for your users. So therefore, you will be able to get more performance. And actually, it will be also easier for you to manage the performance, because now you don't need to have like a huge super duper mega cluster for your app. You will just have like a bunch of smaller copies of your app, which will be much easier to scale. So let's actually get down to that story. So once upon a time, what was happening once upon a time? Once upon a time, I was doing my groceries, and this is the company based in Ukraine. This company, they producing a lot of stuff like food products like ketchups, mayonnaises, and so on and so forth. And they are actually doing the exact same thing that we were doing for one of my clients, who is unfortunately under the NDA. So what was the business need? The main business need was try to go through the digital transformation of that company and also enrich user experience by breaking down the physical dimensions of item packaging. So that company, they produced a lot of luxurious goods, and they want to like get their clients more engaged. And that's why that was the idea, that we can try to break those the physical boundaries of physical dimensions. So what we decided to do, on each item, on each SKU, we printed a unique QR code on the package. Okay, and that's how we were able to identify each and every unique product. Those QR codes, they were printed directly on the factory which manufactured those items, but on the same hand, we didn't know exactly from that factory to which country that shipment will go. So basically, they have like a huge assembly line which produces like, I don't know, thousands of those items per day or per week, whatever. But then they are distributed globally, and we don't have the control over which exact item will go to which country. So that is why when the person will scan with his or her phone, will scan basically that QR code on that package, we need to be able to redirect that person to the local website according to the rules that marketing team define. And also by tracking those scans, we aimed to get more insight on the correlation between the interest and the actual purchase of each particular product. So that was actually a really, really interesting project, not only from the technical standpoint, but also from the business standpoint. And let me try to talk a bit more about the usage flow. So how it actually look like for the client. So let's say that we have our factory. Let's assume that the factory is in Ukraine. So we basically produce that item in Ukraine, and we print, as I was saying, that QR code also on the factory in Ukraine directly on that package. Now we distribute it to the 3 different locations, to 3 other different countries. And for example, when a person in UK will scan that QR code, we want to redirect that person to the local website, something like www.co.uk. When the person in Ukraine will scan the same QR code, we want to redirect him to www.us let's assume that we also have a person in Sweden who will do the same, but for the Swedish market, we don't have a local website yet. So that is why, as a fallback option, we will direct that person to the UK site as well. So this is what we need to configure on our side. This is what we need to create, the way to use the same QR code redirect the person to the local website according to the different marketing rules. So what were the challenges that we faced during the implementation of that project? So the first challenge was how to create a single entry point. And to solve that kind of a challenge, to address that, so the usual scenario will be to go with the services like the traffic manager. The traffic manager is basically a service that allows you to manage your DNS and configure how the DNS will be resolved according to the different profiles, and it will allow you to create a single entry point, like a global DNS name, and then you can connect, for example, your West Europe endpoint, your Japan East endpoint, and your Central US endpoint to that global DNS name, and it will be resolved. If we are talking about the performance profile, then it will always be resolved to the closest host to the actual user, and also in case if the central US for any reason will go down and the health checks will start to show that that part of the region is unhealthy, then the traffic manager will automatically basically remove the central US region and all traffic will go only to the healthy regions. Unfortunately, the traffic manager, and I do like this service, but the thing that I don't like about this service is that it's allow you to only manage the DNS. So it's really cool, but it's not always enough. So that's why, as an alternative, a bit more complicated service, which actually addresses the challenge from a totally different angle, this is the Azure front door, because the Azure front door allows you, so it intercepts the traffic, first of all. It's not only resolves the DNS name, it intercepts the traffic, it allows you to define your routing rules, it can handle the SSL offloading for you, it has the web application firewall capabilities, it allows you to do the VNet integration in case you want to ensure that all of the traffic that goes into your app will need to pass the front door first, and actually much more features. But I don't want to talk a lot about that. I want to jump into my first demo because I don't have a lot of time, and actually this session, it was originally created and meant to be like an hour and a half, but I have only 30 minutes now. So what I have here, I hope you can see my Azure portal. I've already pre-configured some infrastructure, and the points that are interesting for us are the following. So first of all, I have two instances of my Azure function. Both of them are using consumption plan, and as you can see, one is deployed in East Europe, the other one is deployed to East US region. I can actually go through each function directly. That's not a problem at all. Let me just show you. I've deployed a sample function there, so I can just call it like this, just to show you that something is there. And I can also try hello PyDay, for example. Yeah, name PyDay. Okay, it works. So the Azure function actually works. It's based on Python, of course. And what I have here, the first thing that I would like to show, I have the traffic manager profile. So if you will take a closer look, then the domain name for my Azure function now looks like PyDay Demo West Europe, for example. But if I will go here, I have a totally new domain name, which is PyDay Demo TM, TM for traffic manager. So let me just copy this guy and let me try to paste it here. And yeah, as you can see, it's 404, not found. And probably you also noticed one detail. So it says not secure, and we don't have a valid HTTPS certificate. But this is actually how it should be. I can go to sample. I can see the same response as I showed you before. The reason why we don't have a valid SSL certificate in the case of the traffic manager, but we do have a valid SSL certificate in the case of Azure function, is because the traffic manager will only route the DNS for you. That's it. So if you want to add the support for a custom domain, you will need to bind a new custom domain name to this traffic manager endpoint. That's the first thing. And then the other thing, you need to manage all of those certificates by yourself. You need to go to each and every instance of the Azure function and then basically put the certificate there, which is doable, but still this is a lot of unnecessary work. What I also wanted to show, I want to show that my traffic manager is connected to two different endpoints and they are working fine. And I can go to the configuration, and as you can see here, I can choose the routing method. I can choose the monitoring protocol, the URL, which is sample, and so on and so forth. So it's really customizable. I can configure a lot of things here, and everything will work like a charm. The second option, the Azure Front Door, as I was saying, the Azure Front Door will do much more than just DNS resolving for you. So the Azure Front Door also has its own domain name. Let me try to access this one. And I will go to sample. Yep, it works fine. And let's do hello AFD for Azure Front Door. Yeah, hello AFD for Azure Front Door works as well. So what the Azure Front Door can offer you when we're talking about creating a single entry point for your globally distributed solution. So let me go to the front-end manager, because here I will show you everything basically on one plate. So first of all, it allows me to define my origin group, and now I have only one. I named it backend. And if I will go here and expand it, oh, sorry, no, I need to go here. Yeah, if I will go here to the backend, you will see that I actually have two endpoints here. It's again my East US and my West European endpoints. If I want, I can enable the sticky sessions or the session affinity, as it's called here. Usually I don't do that. And if you have an option not to use sticky sessions, then please don't use sticky sessions. I can enable health probes if I want. I basically can configure the health probe in the same way here, providing the path, providing the method, the interval in seconds, and so on and so forth. And for each endpoint, as you can see, I can configure that for this endpoint, it's the app setting, and this is this app service, and this is the actual name of my app service. So everything is working out of the box. It can actually work exactly the same even if you have your infrastructure deployed somewhere else outside Azure, because if I will add a new endpoint, you can see that there are a bunch of different types of endpoints that are supported here. So I can go with public IP address. And if I will choose public IP address, that basically mean that I can route the traffic to any point in the world. I just need to know the exact IP address. But also, there are a lot of native Azure services that are supported out of the box. And for those services, the configuration is simplified, and it's much easier to handle that, especially if you're just starting to work with this service. And also, I have one associated route to this backend pool. And oh, okay, sorry for that. I probably need to go. Oh, no, sorry. This one. Yeah, sorry, I just clicked in the wrong place. So I do have one associated route, and for now I have only one public domain name that is binded to my front door. And this is this name. It looks a bit random, which is also a fact. But the reason for that is because all of those names should be unique across all of the data centers across the entire world. But you can easily bind your own CNAME to this endpoint, no issues at all. And furthermore, you can not only bind your own CNAME, you can also ask Microsoft to provide a free managed SSL certificate for you. I mean, like, how awesome is that? So additionally, I can define the pattern to match, and in this case, I will match basically any URL. I will accept, as you can see, both HTTP and HTTPS protocol. I can say that I want to redirect all of the traffics to HTTPS, and that redirection, it will happen on edge. So let me talk a bit more about the Azure front door. The Azure front door, it's a service that is always deployed globally across all of the data centers simultaneously, but not only that, it also will be deployed across all of the points of presence, which you may also know as the CDN nodes or edge nodes, which basically means that when the user will send the request, it will not hit the Azure data center directly, it will hit the edge node first. And if you have this option selected here, then the traffic from the HTTP will be redirected to HTTPS directly from that edge node. And additionally, because the traffic is intercepted by the front door, it's another awesome thing, because in that case, Microsoft will guarantee you the quality of service for a network connection. So now you don't need to think about, okay, how my user will connect to my endpoint if the user is located, for example, in Ukraine and my host is located in US or something like that. No, you will hit the closest point of presence, and then from that point of presence to the actual host, in case you have it in Azure, the traffic will go through the Microsoft-owned network, where Microsoft will guarantee the quality of service, as I was saying. Yeah. Also, what I have configured here, the traffic from this domain that matches this pattern will be redirected to the backend associated origin group. And the forwarding protocol will be HTTPS only. That basically means that even if I will disable that, the traffic will hit the front door with the HTTPS protocol, but the front door will redirect that traffic to the original endpoint using the HTTPS only. Or I can do match request or something else. And also, if I want, I can also enable caching, because front door can also work as the CDN for me. So those were really kind of a quick explanation of all of the features that you have here right out of the box. But another thing that I also like, unfortunately, I didn't configure anything yet, but you can configure your custom rules. And when you're configuring your custom rules, let me try to do that really fast. You can say that you can add a condition. For example, let's say that, I don't know, request file name contains, I don't know, PNG. Oh, sorry, I need to hit edit here. Contains PNG. Then I can also do like to lowercase, for example, to make sure that if it's PNG capital or something like that, then it will hit this rule. I can add an action. I can modify request header, modify response header, and do a bunch of other things. So there are a lot of applications for that one, but the one that I want to at least partially talk about will be the, let's say, security application. And by security application, I mean the following, that usually when you create an API, the API can expose with the HTTP headers, same as the website, by the way, it can expose to the HTTP headers some additional information about the, I don't know, like which web server we're running on, which operational system we're running on, and so on and so forth. And you don't want that information to be public. So in this case, you can define your own rules, and you can modify the response for, we can modify the response header for all of the responses, for all the traffic basically that goes through your front door. And in that case, that will be one more option for you to also increase the overall security of your setup. So yeah, really cool service, really love it, and definitely recommend to try. Let me actually get back to my presentation, because I can see that I have only 10 minutes left, and I also want to talk about a few other things. So things about the global presence, and this slide is actually a bit outdated. I know that there are definitely more regions now, and also on this slide, as you can see, the Poland region was just announced, but now the Poland region is up and running. So the idea about the global presence is that the Azure was pretty much the only option for us when we were choosing between three different global cloud providers. And the reason why Azure was pretty much the only one option for us is because Azure has the biggest amount of data centers that are basically deployed all around the world. So the goal of the company was to deploy the API as close as possible to each and every user. So that's why, as I was saying, basically Azure was pretty much the only option for us. But now when we're talking about creating a host for our API in each and every region, and there are a lot of them, let's talk about the next challenge, the reasonable cost of ownership. And for this one, I would like to talk a bit about the consumption model of each function. And as you can see, the issue with the regular VM or similar services deployment where you have the fixed, let's say, amount of dedicated resources that you request from the vendor is that at some point when you will need to scale, of course, you can configure auto scale for Azure Container Apps, for the VMs, for Azure App Services, and so on and so forth. But you always need to scale up front. And usually the recommendation is to trigger the auto scaling when your utilization reached around 70% of the CPU. But the thing is that, for example, at this point in time, as you can see, you will need to scale, but still all of that capacity that you have here under this area, it's underutilized, but you need to pay for that. With the consumption plan, you get the true taste of, let's say, pay-as-you-go cloud pricing model. Also, when you need to scale down, you always need to scale down with the delay. And the reason why you need to scale down with the delay is because scaling up is not instantaneous. So even when the load is gone, you still, just to be sure, usually wait like 5, 10, or whatever minutes before you trigger the scale down process. And also you, in most of the cases, will need to suffer from over provision of your resources because when you are requesting, let's say, a new instance of your host, if it's the VM or if it's the app service, you cannot request, I don't know, something like 2.1 CPU. You need to request either 2 CPUs or 3 CPUs. And in this case, if you need more than 2 CPUs, or actually it's more than 3 CPUs, you need to go for 4 CPUs. You cannot choose like 4.1 or 4.2 that you need to actually cover this load. And also talking about the reserved and on-demand capacity, this is, as I was saying, the big benefit, at least to me, of Azure Functions is that when you have a reserved capacity, you can imagine that as a funnel, and the bottom, basically the bottom area of the funnel, it's your reserved capacity. And the top area of the funnel, it's all of your users that are trying to submit some jobs to your app, whether this is the HTTP request or anything else. So that's why with the reserved capacity, you, in most cases, will have something that is called queuing. But with the on-demand capacity, you can imagine that as a scale, and on one side of that scale, your users will start basically putting those jobs, and on the other side of the scale, the cloud vendor will start putting the workers to basically balance the amount of load with the amount of compute resources that needs to handle that load. I will skip the slide about pros and cons of Azure Functions because that was already mentioned, I do believe, even a few times during the presentation. The most important part is that you can run your Azure Functions not only in Azure. You can run them on premise, you can run them in Docker, which means Kubernetes, you can run them locally. So this is the really, really good and flexible framework in a way that you can literally run it everywhere. So challenge number 4 was the cold start, because when you're just starting your app, if it's cold, it needs to do a lot of stuff before it will actually run your code. When it's warm, it runs your code directly. The way how we actually solve that, the way how we handle that, it's a very, very easy thing. We handle the cold start with the health probes. So we configure the Azure front door, and we configure the health probes to continuously have all of the instances of our Azure functions. And if we're talking about the Azure functions, let me pull this information up. This is the pricing model of the Azure functions. So with the pay-as-you-go for the consumption model, you will pay literally peanuts for those health check endpoints. I don't have the math right now, but I do remember that when I was calculating that for the other project, the price for the health check endpoints was something like $2 or $3 per month for every new region to keep it warm just because of the health check endpoints. So you can imagine that comparing to the entire price of the entire infrastructure, paying like even $5 extra bucks for keeping your app always warm, it's a really good deal. Basically the only one more thing that I would like to talk about was the last challenge, because now what we also need to do, all the traffic will go through the front door. The front door will add a specific HTTP header, which called x-forwarded4, and that header will show you basically what was the original IP address of the user who sent that request. So the challenge number 5 was to have an engine that will allow us to basically map the IP address of the user to the country code. And we had 3 options for that. So first of all, we had an option to use a third-party service, but we didn't want to go there because first of all, that's extra latency. Second, that's extra dependency. We don't know how to manage the basically uptime of those services. Of course, we can always believe that the vendor will do their best, but still, if there is an option to avoid that, then we wanted to avoid that. The next option was to go with the SQL database, or maybe like the no SQL database, but we didn't want to go there as well because of the cost, because we wanted to deploy that database again as close to the function as possible. So the function needs to be deployed in every region. So that database or that engine needs to be also deployed in each and every region. So that's why we went for the option number 3, the key value store. In this case, we were using the Azure Table Storage. And for the Azure Table Storage, this is again probably my second favorite service after the Azure Functions. The idea there is that Azure Table Storage allows you to store a lot of data and allows you to do that really, really cheap. And if you're always accessing those data by well-known key, then it will show you a tremendous performance. So really, really recommend that. But unfortunately, the Azure Table Storage, because it's not like any other database or data storage, it needs some re-engineering. So, but if you will apply a little bit of the elbow grease to that, then that will work as well. I know that was really fast, but I tried to squeeze as much as possible into that presentation. So for now, that's it. Thanks, guys, for your attention. Do we have any questions?
That was so awesome. I wish our streaming service had like features where we could put up like a whole bunch of claps or confetti or celebration, because that was awesome. I've never seen anyone take an hour-and-a-half long presentation and put it into a half hour where it still made perfect sense, and it was awesome. Not only that, but also you're at midnight, so many rounds of applause. Thank you so much, Anton. This is wonderful, and we're so thrilled to have had you here today with us.
Thank you. As for the questions,
I think you've answered pretty much all of the questions that I have seen. So I think we got lots of thank yous and way to go, awesomes.
Cool.
So I hope you sleep well and get some good rest after that. Your energy was awesome for being so late. So I hope you didn't have too much caffeine to keep you up all night.
No, it was just 10 cups of coffee, so that's a regular day for me.
Oh, good. So you'll be able to sleep perfectly fine here in a second.
Exactly.
Thank you, Anton.
Okay, thanks everyone. Have fun. Bye.